Hi, I'm John. This is my A-star pathfinding implementation with a bunch of other bits and pieces like broad face, which I'll describe later. So let's give it a shot. It took more than 2 milliseconds that time, and that's because the profiling the profiling works. It just captures everything that happened in the process. And in the process, in the first time, a grid is allocated, a few grids, and a few variables, which are, it's quite expensive to do that. So 2 milliseconds the first time. I expect the next time when I press spacebar to be a little less. And yeah, it's a little more than half of a millisecond, which is pretty nice. Let's try again. A little more than half, about the same node as well. Same target as well. Let's try again. And here we have a very non-zigzaggy and direct path because the path is direct because there's no obstructing nodes. Everything in the middle is walkable. And how that's done is the line is rasterized, and for every single node that the line touches or the line is on, it's the node is checked, and if the node is unwalkable, then that means that we need to go on and run the pathfinding algorithm. But if it's walkable, then we can, if all nodes between are walkable, then we can just draw a straight line from the start to the end. And yeah, just give it a few more times. It's pretty performant, usually no more than 1 millisecond, especially for a straight path. This is, I think, an important feature for RTS games, for pathfinding, because a lot of paths are going to be straight. They're not going to need pathfinding. And so this quick broad face would just make things super fast and super easy. So this is some of the code involved in the pathfinding. In the beginning, I just implemented the stock A-star pathfinding algorithm, which I based on Sebastian Laig's tutorials, which are really great, clear, and concise. And he provides source code too, so definitely check that out if you're interested in finding a place to start. I'll post that link down below. And later on, when I just had too much free time on my hands, I added another optimization, which is a broad phase, which is, as I've mentioned before, just to check if there's pathfinding even needed, if there's a straight path or not, direct path from point A to point B. If there's not, for example, this one, then if there's not a straight path, then we'll just run the A-star pathfinding algorithm. I used the Breezenam's algorithm, rasterized kind of the line segment formed by the start and end positions for this test of to test if there's anything obstructing the path. And this was based on Eric W's implementation. And I'll post that as well, is where I found the source code. So yeah, thanks for watching. Happy developing.